Oh, welcome to Chapter 6. I told you after you got through Chapter 5, things would get a little nicer. Uh, I'm assuming that you've already looked through Lesson 6.1, and it probably looks like there's a lot of work. But what I'm going to do is I'm going to assume that you've paid your dues in Algebra 2, and that you're ready to move on to some quick tools to do things easier. I think everybody's up for those kinds of things, and we got a lot of tools available to us on our calculators in order to do what we need to do. I do want to show you where these things come from and what you are doing when you use your calculator. So I'll be showing you both from the Nspire and as well as the TI-84 how this all translates. So today's lesson is lesson 6.1. We're going to do the whole thing one fell swoop: multivariable linear systems and row operations. When I say multivariable linear systems, I'm saying systems of equations, and I'll show you an example of that one and how this works out. So hopefully you've already put in your objectives and done your vocabulary out of your workbook. If not, you need to go ahead and pause and go back and do that, and then come back and we'll finish up this stuff. Okay, so here's our two objectives. First, we're going to solve systems of linear equations using matrices and Gaussian elimination. And secondly, we're going to solve linear equations, systems of linear equations using matrices and another process called Gauss-Jordan elimination. You're really going to like this. You're going to be so happy. So we start off with something like this. This is one of the systems of equations that's in the book. Usually we have like a bracket on the side that connects all three of these lines together. This would be a three-dimensional line. You got three dimensions, x, y, and z. And I show you the big one so you get a little scared at first. We start off in algebra with just doing x and y equals a number, and another equation, x and y equals a number. Here we got x, y, and z. And we said we could solve a system of equations using all kinds of different methods, and we went through a whole bunch of things. We could do substitution. If we had something simple, we could solve for one of the variables and then plug all the stuff that it's equal to into one of the other equations. We can use elimination. For instance, these two equations here, you can eliminate the y by combining them. Advanced substitution, which is a little crazy, you can graph it. In this case, it would be hard because you've got three variables, three directions, an x, a y, and a z plane. Later on, we'll learn about something called Cramer's rule, which is a nice, quick way of solving any of these kinds of things. And then we can use our TI-84 and the Polysmalt 2 application to solve pretty quickly. And I'll show you what that thing is actually doing today. Or we can use today's methods. And I think you'll probably use today's methods more than anything else, or Polysmalt. But you'll probably want to use this one because you feel like really smart, and especially when you get an answer really fast. Okay, so the first one is Gaussian elimination. That's the first process that we can use in order to simplify one of these systems of equations. We'll start with one that has three equations to it. We're going to transform a system of linear equations into this thing that's called row echelon form. What's an echelon? I want to show you. I'll show you I'm pronouncing it correctly, and an example here just from the dictionary. Okay, here's how you say it.
Echelon.
Right, of course, that's what I said. So as a noun, an echelon is a level or rank in an organization, a profession, or society. So you think like a triangle, rungs and tiers and things like that. But in military terms, it's a formation of troops, ships, aircraft. Usually see airplanes at an air show, or vehicles in parallel rows with the end of each row projecting further than the one in front. So you have three airplanes and then two airplanes and one airplane. Okay, you got like a triangle of airplanes and they go flying past at the Super Bowl. That's an echelon. So we're going to do that with these. We're going to have it so that it forms a triangle. We're going to have three variables and then a line with only two variables and a line with only one variable. Okay, and I'll just show you this one here becomes, if you drop it down into this row echelon form, it becomes this. 1x minus 1y minus 1z equals 7. That's just that top row that got divided by 5. And then we do other operations to get it down so that it starts with y, z, and then the third row starts with, and it's only got z. Or just drop those zeros out there and you can see echelon form. This one sticks out one further than this one does, which sticks out one further than this one does. And once you get to this point, it's pretty easy to solve. You see that z equals 1, and so you can plug a z into the second equation here, and you'll have y minus 4 equals negative 5. You can solve for y, and then plug the answer you get for y and z into the top equation and solve for x. That's still time-consuming, though. And you can make a lot of mistakes in the middle in there somewhere, and then just be totally frustrated with that, which I'm sure you experienced a little bit of that in Algebra 1 and Algebra 2. The shortcut here today is using matrices, using an array of numbers. You could put it in a spreadsheet, but there's a special format on our calculators for doing that, and I'll show you where that is on our little, where all this stuff goes. You're gonna use a process that's similar to synthetic division. Remember synthetic division? We took a polynomial, we took out the x squared and the x, and we just played around with the coefficients and just had the constants there, and then went through a process to get to our answer really quickly. Then we plugged the x's and stuff back into it when we were all done. So a similar thing today, we're going to take that system of equations, we're going to drop it down to a thing called an augmented matrix. That's a matrix that takes out the x, y's, and z's as long as we keep them all in the right columns and rows. An augmented matrix, and then we're going to put this thing in row echelon form. So it starts off like this. You see here we've got our system of equations, 3 equations, linear equations, and if we drop it down into augmented matrix form, this is what we get. So I took all the x's and the y's and the z's and even the equal sign out. The book has a little dotted line right here between the third and the fourth columns, but this is what you get in a matrix. You get this bracket thing, and you just use 5, negative 5, negative 5, and 35. In the next row you go negative 1, 2, negative 3, negative 12, and the third row 3, negative 2, 7, and 30. The calculator understands what you're doing here. There is an operation then in the matrix menu which is called RREF, reduce row echelon form, and when you hit enter on that, it becomes this, and this is in what's called row echelon form, and this translates back into our system of equations. There's 1, negative 1, and negative 1 turns into 1x minus 1y minus 1z equals 7. The second row basically starts right here at 1y minus 4z equals negative 5. And then we got our third row, so it takes out stuff, it simplifies it, and if you went on for the answers, you get 7, negative 1, and 1 for x, y, and z. Generalized in row echelon form, oops, I'm going to take out that, I did that several times. We get this, it should be 1, number, 0, 1, number, 0, 0, 1, number. All this stuff always stays the same over here. That part never changes. That's row echelon form. If you're interested at where to find those things on the calculator, you will go to the menu, and you see you got a category matrix and vectors, and you will choose row echelon form if you want it. We're going to also use this one, reduced row echelon form. You just click on that, and it gives you this thing. If you want to put in a matrix, well, then you use this button right here. And you want to make a matrix that's not this size, this size, you click on this one right here, and it asks for number of rows and number of columns, and we're using ones that are 3 by 4, and it pops it up there. You just plug the numbers in, and off you go. So that's how you use that. That's a great tool. As long as you just get used to typing the things in and then pushing enter, you're going to get your answers. You just have to recognize how to read the thing when you're done. And so I'd say go back about a minute or so, and remember that when we get this type of matrix here for our answer, that translates to this type of system of equations. Of course, then you still have to do a little bit more math in order to solve. And so another guy comes along and says, okay, Gauss's method was pretty good, but let's go a little bit further. And on the sidebar of page 369, you get a little study tip there, which shows another process for going through. And I've taught myself that, but it's rather time consuming. So we're just going to cut to the chase of what Jordan did here. And it follows an extended algorithm. It goes beyond the Gaussian elimination in row echelon form to get to the final answer in matrix form. And this one's called reduced row echelon form. Form, or RREF on our calculators. Remember I showed you where that was? And then using the little menu. So, called reduced row echelon form, and it looks like this. It's a little bit different. It's all ones and zeros over here on the left side, and you just get your 3 constants in the last column. Or you can think of it like this. That 1 means that the x column is on. So the 1 means x. There's z, y and z are not on, and whatever is up in the third column, there's your answer for x, there's your answer for y, and there's your answer for z. Okay, first column is the x column, second column is the y column, and the third column here is the z column. The number that ends up in the last column is your answers for x, y, and z. If reduced row echelon form doesn't produce a matrix that's in this form, either it has no solution or infinitely many solutions, like you'll see in example 6 in your book. And if that's the case, if you're graphing these things, no solution means that the lines aren't ever going to cross each other. They're parallel. Infinitely many solutions means that 2 or more of those lines are the same line, and so every point is an answer, and you never get one x, y, z answer. Well, that's no good. We don't like that at all. So let me show you how this works in a couple of different ways. I'll go back to my calculator page here, and I'm gonna get rid of this, and I'm gonna put in this one right here. Okay, I'm going to copy that sucker, and I'm gonna put it right in here. And I'll show you what happens when you take reduced echelon form. Actually, I don't want to do that. I want to do matrix and vectors. I'm going to do reduced row echelon form. Back up just a smidge here. Okay, I think we're ready to go. And it turns into that right there, which I already told you the answer for that matrix was 7, -1, and 1. There it is. You could even go from the very beginning, and you could pick reduced row echelon form and use that matrix up there. I don't want to retype all this stuff, so I'm just going to do this. Okay, now you start off with that matrix that I gave you at the very beginning in the linear form, and I just hit enter, and I go boom. There's my answers. X is 7, y is -1, and z is 1. And you feel so good about yourself because there it is. There's the answer right away. If we were using our TI-84, we would go to the apps and find the polysmult. And I have the old version here, so it'll look a little bit different than yours. But it's number 2, the simultaneous equation solver. When you do this, you say how many equations, how many unknowns. As soon as you do that, I go enter, enter. Then it gives us, it says, okay, well, here's a matrix. And you plunk in all your numbers, and you say crack or solve. And this is basically up here. This is an augmented matrix. And when you hit solve, it goes through those row operations that you see in your book, and it gives you your answers. There's x, there's y, and there's z. Now I'm going to go back to this, and I'm going to do one of those on number 6, example 6a that doesn't really work very well. Okay, so I'm going to go ahead and type this one in. Say there's -5, -2, 1z, and 2. And then the next row goes 4, -1, -6. 4, -1, -6. And our coefficient is 2. Or sorry, constant is 2. Third row, -3, -1, and 1. That equals 1. And I got all the numbers in there, and I say solve, and this time it's kind of confused. It's like, uh-oh, no solution found. But it does have this, and it says, what would that look like in reduced row echelon form? This is beautiful because right away you don't have to translate anything. You see, got a problem here. So you push the reduced row echelon form, and it'll back up one screen, and it'll show you what it looks like. And see, this doesn't go 1, 1, 1. Should be a 1 right there if this is in reduced row echelon form. It's not. So this actually would mean x minus z equals 0. This would mean y plus 2z equals 0. And this just means that nothing plus nothing plus nothing equals 1, and that obviously can't be true. So that's a cool one if you're working with something from example 6 or 7, where you're trying to find out if something has no solutions or infinitely many solutions. For everything else, you're going to go and use reduced row echelon form, ask it to put a matrix, plug the numbers in, hit enter, and then interpret your answer over here. That's it. The numbers that you're supposed to do are on your sheet that I gave you already, and feel free to use those tools as much as you want to. Get used to typing in the matrices. Remember, your magic button is right here, and it's this big one here where it's a 3x3. You click on that, and it allows you to pick how many rows and columns that you'd like to use. Reduce row echelon form, and row echelon form, you go menu, you find this one here, matrix, and whatever that said, and you pick either number 4 or number 5. There you go. Have a nice day.